And so it will know I can actually control specific things. Hit enter on that first choice. Select imaging area. And you'll see it's building a map, and then it's actually reading the partition structure and the physical data. Hit enter again. Now, everybody at this screen yet? So, yep, Alt-A. Okay, enter. And then wait right there. Everybody else there? Yep, okay, good. Alt-A. Enter. Yep. And then it'll take a second, and then after the partition structure comes up, then hit enter, and just wait right there. Everybody else good, 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 good. Okay, Shift Tab. Shift Tab will take you up one dot, and then you have to push spacebar on the dot. So we're going backwards is what we're doing. Shift Tab. Do it twice, I'm sorry, till you get that purple dot. Till the purple dot is around that little outline. And then you hit spacebar. Everybody got that purple dot. So we're moving the purple dot up one. Good? All right, everybody good? Any problems? Good. Hit enter. Now this is reading files, indexes, and bitmaps. This is known as allocated space, not unallocated space. The files that you have deleted and the content that's already old on the drive comprises a big portion of the drive. So we may not want that data. Most data that people want is the allocated data. They want what they used to have. Everybody good? Can you help us here for me? Yeah.
Is that right?
Yep, hit spacebar.
Spacebar?
Yep. Hit spacebar.
Oh.
Yep, there you go. Now stay right there. So as soon as we hit enter, what it's going to do is it's going to read the MFT entries for files, the folder structure, and then what's called the bitmap. And the bitmap says I'm allocated or I'm unallocated. And this way, if you only have 25 gigs on a 500 gig drive, you only copy the 25 gigs. So it actually will parse this. So I'm going to hit enter. Ready? Enter. Now, it'll say loading the MFT table. It'll go through reading the MFT table. It'll start copying the bitmap table. And then eventually when it's done, so this particular drive has 74 gigs of data on it. Everybody get a similar thing? Yes? So this now, you'll see these check boxes. These are now allocated locations. That's a file entry. That's actually a file. That's a physical file. This is the MFT entry that points to a file. So if I hit F3, I can see that as I scroll down. You can see this is the system folder. So system volume information. You can see it down here in Unicode. This is called Unicode. System volume information. So I can see, and you may not be on the same sector I'm on, so I don't know if you're on the same sector or not. But now this is where I'm going to be copying the content that's specific to these folders. So I'm going to hit OK again, so I'm back to the screen. Now, I need to tell it to go and image this content. So I hit Control S. And now you'll see there's a continue from that last known state. Control S. As in Sam, start. Everybody good? S. Sam. Start. Yes? No? Yes? F5. F5. Okay? And then you hit enter. It's only going to image the allocated data now. So it's 75 gigs, so that's a significant portion of the drive. But if this was a 500 gig drive, it'd still only image 75 gigs because that's the allocated portion. So now that's not going to get me the content that's unallocated, which might be important to forensics people, but these are the differences between your choices. You can be more intelligent about what you're going after depending upon what type of problem you have. And this works even in like RAID arrays and things like that. You do them individually and then you reassemble them. So you can do those things as well. RAID arrays, you can do SAS drives, you can do a whole bunch of things. Now, there is a separate controller for SAS, but it's possible to do any of these things. And it does the same process. You can see it. I'm not going to explain every single thing, but you know, roughly 12, 13, 14 minutes, we're going to have a copy of everything that's on this drive. And so other than the fact that I had to talk to you for an hour, we'd have been done pretty quick. Right? Does that make sense? So that's fundamentally at least this one particular piece of how you can start and you can do things logically. Now, I'm going to switch to the Atola. And so the one that's the laptop in front of everybody, I'm going to try to do the same thing. I'm going to try to show you what the differences are and some of the stuff that you can actually do with the Atola. So the Atola sitting in front of you. Now, I need to make this clear to everybody because it takes a little bit to kind of get used to the interface. Even if it's a Windows interface, you could plunder through it and it'll only take you a few minutes to figure it out. But I've already added in your destination drive. It does not normally come, like normally you have to add in everything manually. So you're going to say, this is my source drive, this is my destination drive. And so I've done that. Here's the source drive on your left. On your right, I have a destination drive. So let me show you what happens. See this whole long list I have of items that I can do? That list is also available when I'm over here on this drive. I can actually do functions associated with that other drive. Now, right now, the drive on the left is write protected. Right now, if it was not write protected, it shows a bright red box because you can screw with it by accident. So right now, everybody's is. You don't have to do this. There's a little physical switch on the front of the drive. And if I was to turn that off, you see that red bar? That's bad. If you're doing forensics, if you're doing data recovery, you should not be modifying your original drive, which is also the problem with SpinWrite. It modifies your original drive. So I'm going to flip it back up so you can see, because you should never really turn it off. It should always be in write protected mode. There are times where you might want to do like rejuvenation of a drive and put it back in a system or something like that, but we're doing recovery. Now, the box at the top, click on the second hard drive. Just click on it. And you will see you have another set of menus. So every time you switch from one thing to another, there are different actions you can take. So you could keep adding drives to this list and work on multiple drives. You can work on multiple targets. You can add USB drives in. You can have them being imaged. You can have a number of things going on at the same time. Okay? So just understand that as you switch back and forth, you're taking action on different drives. Now this drive is writable. I can write to this drive. The other one is protected. That one is writable. Okay? So now we're going to switch back to this drive. So I just wanted you to see there's a difference between these two. So, that red bar, oh, this one's always writable. Anything except for the source drive is always writable. So the source drive is the only ones that are protected. So that's why when I switch off the switch, I got that red bar. So now, because in forensics, you would normally be making a copy of a drive that you are then going to copy to 3 other drives, and you're going to give one to the prosecution, one to the defense, and one's going to go in a safe. And that's how that's going to happen. That's what's supposed to happen. Let me tell you, police never do that. Just never happens. They don't make backups. They don't. I've been on a lot of cases. Original drives lost. Long list. Anyway, just doesn't happen. So, all right. So anyway, we're going to switch back to the first one. So we're on this first drive. Now, this is the one, we don't know what's wrong with it, right? We're going to try to figure stuff out. We can turn the power on and off individually on these drives. Yours should say on right now. And just to be sure of that, hit the button that says re-identify. Hit the button that says re-identify. It should refresh, basically. You should see a little box pop up, and then it should look the same. And as long as that happened and nobody got any errors, everybody happy? You got an error? No? Good? All right. Now, we're going to take action on this. We don't know what's wrong with this drive, but we did get lucky. We did get serial number, model number. It did do a drive seat complete. You see these lights down here? They're down at the bottom on this particular tool, whereas on the other tool, they're at the top. So on this one down here, we've got a physical link, and we have drive seat complete, drive ready. These are all error and status lights. There's a lot more that we can do here, but I'm not going to go into that. Right now, what we want to know is this drive okay? Now, the other tool you saw did not have a real diagnostics mode. We went immediately into imaging. If there was something wrong, we'd have to determine what was wrong and fix it. If the board is bad, if something else is bad, we'd have to figure that out. Understand? In this particular case, Dimitri wrote this tool to try to solve the problem of what's wrong. Now, he's right a lot. It's not always 100%, but it's pretty solid. because it does test boards and things like that. So come down to the one that says diagnostics. Click on diagnostics, which is the second one, right? Now underneath that, there's an item called automatic checkup. You see that? So click automatic checkup, and you should see this. Yes? Hit the start button. That's where the cool stuff happens. It goes through a process. It powers off the drive. It has 5 stages, and during those 5 stages, it's looking at a lot of stuff. It's trying to say, is your circuit board okay? Powers it off, pumps some data into it, pulls the data back out of the circuit board. It's actually memory. It's got everything exactly like a computer does. It has a processor, it has memory, it has storage. So it's doing that. It's checking power consumption. Then it's looking to see whether or not it can write to the registers. It knows if it's reading data from the system area. Then it's checking every single head. It knows there's 2 heads. So it's detecting them, going through the process, and then performing a test on each one. So in a minute you're going to see, so it's doing head by heads. You'll see it going across the top. And then it did a test to see how fast they were reading. So it actually checked them in milliseconds to see whether or not you could actually talk to both drives. If one's slower, it would actually say, this one's degraded. Maybe you want to turn it off, but it still works. So you can actually say, this is the slow part. Let's not grind on it. Let's read all the other heads, and let's come back and do that one last. So you can actually make those choices. Everybody understand what I mean? There's a lot of intelligence that's going on here that tries to help you as it goes through this stuff. So it knows we have partitions, and it told us it was NTFS. So all that stuff I did earlier where I had to hit F3 and I learned that it was NTFS, this one's trying to tell you that stuff automatically, so you don't have to be as brilliant to find this stuff out. It sure helps to be brilliant, but I'm just saying it will help you in that process. So now, it does a report, and this is a nice printable report. It's one of the few tools that actually does this terrific report. So as you scroll down, so I'm going to scroll so you can see, and it'll try to give you an idea if there's something wrong with your drive, what you should do about it. So in this case, it compared these against power consumption databases, so it knows whether or not the motor is working correctly and firmware is working, knows if the drive's board itself is working and whether or not you should swap it. It then tested in locations. Now, here's the thing. Here's the really cool thing. Certain drives have a problem where a board fails, and you can read half of the drive, but not the other half. And you don't know. You just think bad things happened, and the drive just doesn't read. At some point in time, you get halfway through the drive, and it stops. It's actually a board problem, not a head problem. So that's why he tests in 3 different locations. So he's testing the tracks, outer track, middle tracks, and inner tracks. So he's actually looking to see. Then he's testing individual heads. So he actually looked at the heads by zones and then tested those heads. So there's actually a process to at least let you know what the status of the drive is for all the things we would have had to do manually. And then coming down from there, you actually have a test on those locations in the media. And then it'll actually run against the smart tables and firmware. It spits out these tables before we've even done an image. Checks firmware, and then it actually knows the partition structure. Now, I don't care if it's failed at partition structure or it knows partition structure. I can still image the drive. But knowing the partition structure is an operating system it recognizes helps a lot. It doesn't have to be an operating system it recognizes, because if it's a file system it doesn't recognize, let's say it's IBM and it's an AS400. If it's an AS400, I can still image it. The drive will still image fine, but it has no clue what to do with the file system. I have to know what to do with the file system. Everybody understand? Does that make sense to everybody? Okay, so I'm going to try to show you from here. Now I'm just going to skip from here, and I'm going to come straight down here to the imaging. Okay? So click on the word imaging. Because now I have no data yet, right? I want data. And I can either image the whole drive, or I can try to image a tree. Does that make sense to everybody? So I'm on imaging. Now, the other tool allows me to do 3 different ways, basically doing passes. I can do 4 passes on a drive, but I only have a session that's running all the time. I have to continually manage the session. You saw us, do it. We physically did it. On the drive that was imaging. It's probably still imaging there in front of you. This one I can create multiple sessions and just add to them anytime I want to modify something. So hit the button that says create a new session. Now it's going to ask, where do I want to write to? Everybody should have a drive connected to your system. Do you have that? Yes? Everybody good? All right, so then select the drive and say OK. Select it. OK? All right, now. So now what I'm going to do is I have drop-down boxes. I can do a couple of things. Hit the button that says Select Heads to Use. You will actually see that I have 2 heads and there's a checkbox. I can turn off a head. All I have to do is uncheck it, and it won't image that side of that platter at all. That one side of that platter will be completely ignored. So if I had a report that said I did not want to do that, and they were degraded for some reason, I can uncheck it, and I can do one at a time. I can check one, image it, turn that one off, image the other one. Or leave it on, it doesn't matter. It doesn't reread any data it already read. Neither of the tools do, the Deepspar or the Atola. If they already read it and it's green, they never read it again. Now in this particular case, all sectors would be the entire drive. But I don't want to do the entire drive. I want to try to be smart. I want to image sectors with metadata. That's the tree. I want to be smart about what I want to image in this particular instance. Because the default would just be do everything. And you can do that all day long. So let's click Select Sectors with Metadata. Everybody where I'm at? Yes? No? Okay. Now, I'm just going to show you what you can do. You can hit Show Settings, and you can see what the choices are that are already done for you for passes. So what will happen is, and it'll tell you, we're going to do timeouts. We're going to try to read something, in this case, in 40 seconds. Now, here's the thing. Windows, when you have a hard drive that's in a Windows system and it's failing, it really only takes 600 milliseconds. If it's past 600 milliseconds, Windows APIs just fall apart. They don't know how to talk to a drive. They just call it dead because they're expecting everything to respond in like 7 milliseconds. So 600 milliseconds is a long time. So in this particular instance, we might be able to read sectors by increasing the time. Most of the time, that's all we have to do. That's the majority of the stuff we have to do, is increase the amount of time that we spend looking at sectors, and we may be able to read them 80 or 85% more often than we can read them at 600 milliseconds where Windows just falls apart and fails. Everybody understand? So that's why it's doing these things. It's increasing the time. It's jumping when there's an error so that we get good stuff. So it jumps 100 sectors. But you'll see what happens is it's going backwards. It's using another method of reading the drive called PIO mode, which I can explain. I have a million slides. Then it's going to go forwards and read the next sector, and then backwards. So does everybody's look like mine, or does it say something else? It says something else? Okay. And that just means I played with mine in the process of trying to set up the class. So I tried to get them back to normal, but I probably missed mine. So it doesn't really matter, though. In any of these, you can add a pass. You can change anything you want. So I can actually do, so yours says this for the first one, and then a smaller number here? Yes? So none of the boxes are checked? Okay. It doesn't make any difference. It's just going to do these in multiple passes. So it's going to do one pass, the other pass. So I'm going to save the settings that I have here. Then the next thing I'm going to say is start imaging. And so mine will look a little different than yours when we do it, but it's going to be the same content. So I'm going to say start imaging. And now you're going to see it switch modes. And it's looking at the metadata. It's trying to figure out whether or not I want it or not. Now, it knows I have a destination drive. It's just trying to be sure I'm going to overwrite the destination drive. So if you get that box, say yes. Now you're going to see it made some blue areas up here. So those are the sectors where it's going to try to copy. Now mine's going backwards. You can see it going backwards. So it started out here and came backwards. It's reading sectors, and it's reading metadata. So you'll see it do metadata, then it's going to come back here, read the MFT. So you'll see it doing index buffers, then you'll see it doing file records, then you'll see it doing a bitmap. So it's going to do all these things that try to tell you, and it's being intelligent, it's doing file records, and it's trying to tell you what these things are as it's reading them. So when I'm done, when it gets 100% here, I'm just going to have the tree. That's all I'm going to have. It cloned the tree to the other hard drive. Everybody understand? Yes? What's it say? Yeah, type yes. Yes, hit yes. Okay, there you go. And then everybody's should be going on and on. Yep. And then it'll say imaging results. It'll show you a little picture and it shows you imaging results. And then when it's done, we really have the tree. Now the tree that we wrote is on the second hard drive. It's over here. So the tree, we copied it from here and we put it over here. Does that make sense to everybody? Now if we tried to mess with it over here, it would warn us. It would say, you shouldn't do it over here, you should do it over there. So if you click on that, this is the tree right here, file recovery. Is everybody caught up to here so far? Click on file recovery. Now, if you try to do anything, it should warn us. So hit scan partition. It'll say, oh my God, don't mess with this drive. This is your original drive. You really need to go over there where you cloned it. So say switch to target. So you will see when you switch to target, it will switch to this drive. You say yes and say okay. And now it switches to the other drive. Now we could have done that manually. We just could have gone over there. But I just wanted to show you it's trying to be intelligent, trying to stop you from making a stupid mistake. So, not that you could change it, you couldn't do anything anyway. But, so now we're going to scan for a partition. So this is the part where it's going to say, oh, do I have NTFS? Do I have HFS? Do I have a Mac? So hit scan for partition. So it'll look at the drive. It's going to read that partition table, and magically, we have a NTFS partition. Hit that, click on it so that it's highlighted, and then say Open Partition. Now, you should now have a tree, equivalent to the tree we had over there in the Deepspar when I was showing that earlier. Everybody good? Now, we have My Hot Girlfriend as an example, right? We're going to do the same thing we did before. Click the box that says My Hot Girlfriend. Now you could do individual files if you wanted to, but it'll actually show you that there would be girlfriend pictures on the right hand side, and you can click all the individual files. It's irrelevant. It doesn't make any difference. You'll get the point. Now, all we have is the tree. We do not have the pictures. Everybody understand? We do not have the pictures. It has not been copied to the drive. We only have the tree. We don't have the rest. Okay? Now, at the top, you see a button that says Image Checked Files. That one is the one that says, I'm going to figure out what the layout of the disk is, I'm going to figure out where the sectors are, and I'm going to image them. So hit that button. It'll say, what do you want to do? Yes, I want to do NTFS. Say OK. Say Accept. Now you see it's going to do 1 gig of data. So if this was a criminal case or something else was bad, it's going to figure out that's all I wanted to do was the 1 gig of data, and it's going to make me a custom set that I can then image. So this now switched back to the other drive, made a custom set for me, and now I can image that, and it will log it separately. It will say you did this action. I can now, keep stuff physically separate. I can still do the same things I did before. I can control specific heads. I can play with all my settings. Everybody understand what I mean? Now, I'm going to say start imaging. Now, it did also make me a separate 5-pass, or would make me a separate 5-pass if it was in the defaults, but I changed it already. Then start imaging. And once you start imaging, it's now going to copy only the sectors that have, and you'll see it when it comes across, because if you guys are familiar with JPEGs, so this is a big picture, so there may be other stuff, but when it eventually hits the sector, you'll actually see the umlauts, the Y with the umlauts, it'll be a JPEG, which would be FFD8. That would be what a JPEG starts with, is FFD8, and it ends with FFD9. So in this particular instance, when you see FFD8, that's the beginning of the picture. This is still content. So that's the content, and then you'll see FFD8. Now, it's 250 milliseconds. It's reading faster than that, so I don't see them all from that standpoint. But it's imaging them, and if there was a problem or there was a head problem, I would see it immediately, and I would be able to say, I need to make another choice. Let's turn off one of those heads and skip that, and then do it later after I fix the head or do something else to it. So in this particular instance, it's imaging that data, and then when it's done, I actually can then save those files and look at those files the same way. Everybody understand? So, All right. Now I'm going to show you a couple of other things real quick. That's the basic functionality. There's a lot more functionality. I'm going to let that run. We don't have to watch it. So I'm going to switch to a couple more slides. Now I have made copies of all this stuff online. If all you have to remember is I have a company name. It's called My Hard Drive Died. Really easy. myharddrivedied.com. If you type that, I have a presentation page. So there's tabs across the top, presentations. All the slides, everything that I've done is right here. If you hit the download, I've got one that's already broken down for that folder and that one. Both sets of slides, the slides I'm about to show you as well, because we're going to have some intellect that goes behind this. So this is where we start going from the standard things everybody can do to some more advanced features. And I'm also going to publish this video, or as much of this video, later on as well. So it'll be on that same link if you want this video later, because I am recording this event. I have written material to break all this stuff down into specific problems so that I could try to teach a class on the material. And I've done it. I've been doing it for a decade already. So I've already been teaching every agency all over the world, everybody for every country just about, including Russia, including Lebanon, and everybody. So I've broken this down into the different types of problems and how to fix different types of problems and make things work. And there's a lot of things that people just don't know about hard drives because they are super intelligent things. Those jumpers that are on the back of the hard drives that you've been using for master and slave for all these years, they do a bunch of other things. They actually have ways that you can actually program them to go into safe mode so I can read them and do things to them. So this is where we start going into the advanced stuff. When a drive doesn't work and something doesn't right, there is a special cable. It's really a serial cable. It's what's called the TTL to RS-232 cable, and it will convert things that you can read and write from the drive. So if you know these things, there's a lot of things you can do that are more advanced on these devices. I'm not going to get into all these. Here's another thing. Most people have absolutely no clue. It's the simplest thing in the world. On your boards, on almost every board, especially today and made in the last 5 to 8 years, there's a fuse. It's really the reverse of a fuse. It's called a transient voltage suppressor. It shorts power when power is screwed up. So in other words, what it does is when a lightning bolt hits nearby, or you plug it into a bad power supply, or you do something, it shorts. And when it shorts, it will actually create a power fault. And the drive will never function again. The drive does not function. It shorts them. When they're open, they're connected. When it shorts, it closes them. It's the opposite of a fuse, because normally you look through a glass of a fuse, and there's a little burnt piece of wire, and you can see that. This does the opposite, shorts the board, so it does not work at all. All of the data recovery tools pop up a red box when they detect that. If you plug a hard drive into one that has a short on it, a box will pop up and say, hey, you got a power short, your transient voltage suppressors are bad, and you can take them off. The drive functions perfectly fine if you literally rip them off. The fuse is already bad. So if you rip it off, you're not doing any damage. You can use a soldering iron if you want. The easy way, in 10 seconds, take a pair of pliers, needle nose pliers, you squish it right in the middle and snap the two ends so that these two pieces do not connect anymore. Now, here's the symptom that you have for the drive if you did not have one of these special tools. If you plug this drive into something and you start to try to say, what's wrong with my drive? It doesn't work at all. If you hear nothing, like most drives, the motor is almost a thing that will always work. The motor is really a rock solid piece of thing. So that's the seldom replaced item, is the motor. So if you have a board that supplies power all the way through the board, it will spin the motor and you will hear it. And then nothing will happen. There'll be other problems and other things. If you have a power short, the power never goes past the power. Here's the power connector, and then it comes right out, and that one's 5 volts, and that one's 12 volts. If there is a short on either one of them, that's where it stops. It doesn't go anywhere. You won't hear a thing. Your drive will not make a sound. There will be nothing. If you put your ear to the drive, even if the motor's not spinning, and you hear a power hum, it's probably not this. Does that make sense? If you hear nothing at all, completely dead as a rock, well, look for those too. All you got to do is take the board off, There's no damage in taking the board off. It's 4 screws in most cases. You undo them with a torque, and then you take them off. You snap those 2 little, you put them back on, and even in worst case scenario, you've done no additional damage. The only thing is, you do not want to plug them back into the power supply from which they came, because that could be the problem. So if you plug it right back into the same thing, then you're going to blow it. And once the power gets past this, it destroys the heads, destroys a whole bunch of things. So this is a very simple thing that you can get past. But all of the data recovery tools tell you this. In forensics, if people were just smart enough to know this, I get like 6 of these in a week. I make $800 off of these. It's a good day. It's like literally done, copy the data to a drive and send it back to them, charge them $800. So it's not, as they've said before, it's not necessarily the thing, it's knowing which thing. And that's the whole piece. So I just told you right now. Anyway, you've already seen this. This was actually that F9 button where we showed that there's things that you can do that you can actually change. Head assemblies, G-list, clearing, smart, they're so common. Even things like this. The boards are really easy to fix. When there's damage to a board, the board means nothing. What's important on the board is that there's one little chip. And if the chip is in good shape, you just desolder it. It looks exactly like this. Has 8 legs. It takes 15 seconds to desolder and resolder one to another board. That is the chip that would normally contain the settings that you need to take to another board. So you can go get a good board from another drive, take this chip off, put it on the other board, and you don't need the other board. You don't need to repair the board. You don't need to resolder these things. All you need is the 8-pin chip that goes with it, in most cases. There's exceptions. If you want to know the exceptions, I have a class. Anyway, soldering is a normal part of the day-to-day life, and those are the things. This is what a set of bad heads actually looks like. So when a head is bad, I can still copy from all these other heads. I just have one that's missing. That's the one I can turn off. And if I turn this off, I am able to actually copy data from other platters. I don't need any of this. So this is the basic look of what a drive actually looks like. Again, this is what heads would look like when they're bad, so I could actually read from all those other heads. This is what the zone table looks like. So this is when people go, I think you're wrong, all the data is stored down all the way through the platters. Well, I printed this right off of a real drive. Now, if you look on zone 1, head 0, starting cylinder, you see LBA block 0, and it goes all the way up here. So I've got 2 gigs of data right here on one head in one zone, solid data. That's probably enough for everybody to have their documents and settings folder or something, unless they have pictures. Like that might be a whole nother scenario, pictures and video. But actually, it's worse from that standpoint, like it's not worse, better. On that same head, on the same side, consecutively, for speed, all the zones, it actually goes all the way through this entire process until I get to here. So I've got 6 gigs of data that's solid on one side, on one head, on one platter in a row. So if you're writing contiguous data, I probably have all your spreadsheets. I might even have enough to have all your JPEGs. So that's what it looks like. This is physically what the drive looks like. These are cylinders. This is all the stuff I described earlier where cylinder boundaries matter. The data is stored on the cylinders. Physically, at least, I can actually copy this data. There's the zone table. That data means that this is all contiguous data. So 12 gigs in a row before I get to the other side that I have to deal with another platter. So I can actually copy quite a bit of data. Now, this is when we start getting into things I can start controlling better. I can control the timing of the drive. So when I'm looking at, so as an example, on this particular drive, I want to be able to control timing. Hit Alt-I. Now, there is an item called Settings. If you go down to Settings, so if you just go down to there and hit Enter. Now, you will see there's a couple of choices here, and these are very important to me. They mean something to me, and I'm going to try to make them mean something to you. So there's a couple of items right here. There's this one right called LBA 28-bit mode to 48-bit mode. There's drives that are older that we can only count to 137 gigs. Once we passed 137 gigs, we had to update our BIOSes. And so that was a long time running. That wasn't until like 2002, 2003. So once we updated our BIOSes, we are able to see drives larger than 137 gigs. Well, there was a command that we could use in the previous drives in LBA 28-bit mode that's called ignore ECC. And what that command does is it allows us to say, I know you have an error. I don't care that you have an error. Give me the result anyway instead of 0, which all those forensics tools give you 0 because they don't know how to deal with it at all. So in this particular instance, I can actually use that button to say, I would like the answer anyway. And what happens is you can say how many times I want to try. So I can reread it 17 times, and the best answer falls out. So it will retry and get a better guess every single time. So I can try to read things that normally have errors. Does everybody understand what I mean? I can force a drive to do this because the command is obsolete. It's no longer used in current configurations, but it's for the first 137 gigs. Yes, sir?
Super interesting information. We're about 15 minutes into lunch right now.
Yep. On the schedule, they actually had it till 1 o'clock, but on the online schedule, they changed it to 12:15.
Well, I just want to make sure there's food left.
Okay. Well, that's...
Your schedule, you're going to go till 1? That's all right with me. I don't know.
Yeah.
Going to 1. Okay.
Yeah, they originally had it on the schedule till 1, and then they changed the online schedule, but I think the printed schedule still says 1, right? Okay. Okay. I mean, I've covered the majority of the important stuff. There's a huge amount of stuff. I'm sure you got the point at this point, so if you guys want to go, that's fine. But I just wanted to make sure everybody at least got the point at this time.
Quick question. You mentioned you can set how often you check that sector.
Yes.
Where is that?
So once I turn that on, when I actually go to, there is a imaging process right here. These are the processes I can do, and these are related to these particular commands. Like, for instance, this one right here. I can make a custom one, so I can actually say, I would like to make a configuration A. Then I can go to available configurations. I can make one, and I can tell it, I would like for you to reread this block, and I can say how many times I want you to reread it. So the standard read is 1. If I change this one to read ignoring ECC, I can change this to 99 or whatever, and then those two go together. So there's two situations where that goes together. Additionally, there's another one that's called PIO mode at the bottom. These all have to do with timing. See, DMA is memory, it's direct memory transfer. And when you use DMA, there's a lot of crap that's wrong with DMA and memory on a drive. So turning that off and switching to PIO mode is the original way that we had to talk to drives prior to Windows 95. So prior to Windows 95 introduced the ability to do UDMA and DMA. And so before that, drives were really slow. And they'll be about 16 times slower than they would normally be. But I also may read them, and go is better than no. So I'll take that anytime, no matter what it is, from a speed standpoint or others. So there's so many control mechanisms here. There's a tremendous amount of things, and it's very similar to what I showed you in the Atola as well, where you had multiple passes. You could do timing, you could do control. These are all those same things. They're just individual items along the way from that standpoint. And all of these things matter for a lot of things. For example, memory sticks. Memory sticks are actually all done through USB. USB memory stick, there is no actual SATA. Even if you can get a controller that takes a USB card and turns it into a IDE controller, none of them actually do it. They're all USB interfaces first, and then they convert it to a IDE or a SATA adapter. And so you can't use any of the commands you would normally use. And there's only one exception to that, and that is the CF cards, compact flash cards. Compact flash cards are right here on ATA 5. Back in the day when they came out with these cameras for compact flash cards, they decided that they wanted to make it an ATA spec. So it actually has an interface, and it actually communicates from a memory standpoint just like a hard drive does. And I can plug it into any of these systems and work on it exactly the same as I could a hard drive. It's the only one. There is no other. So this makes a difference when somebody sends me an SD card versus a compact flash card, who professionals are using the compact flash card, so I'm going to make more money there anyway. But at least from that standpoint, there's things like this that really matter. These are the ATA specs. There's a lot more in these specs, but these are individual things that let you know what actually happened along the way. Then hybrid drives and solid state drives and all these things. And all of these things are reflected in each one of these tools, and that you can control them. So you can just have the tools do something dumb. You can just click go, as you've seen already. You can just say go and they'll do it. But if you know how to control those things, that's how you whittle away at the problems. You're taking one problem one at a time, whittling away at them one at a time. Everybody good? So that's where the transfer rates and all the other things are controlled. So these are the 4 primary things that you would deal with, which are PIO mode, DMA mode, using LBA 28-bit and LBA 48-bit mode. And those things are all reflected in the tools. As an example, when I'm imaging, if I was imaging here, you see down here at the bottom on the right-hand side, there's a P4. P4 means I'm in PIO mode. 4 means 48-bit mode. So that means to me, if I want to do, and I was having problems in the first 137 gigs, which the important thing that's in the first 137 gigs is usually the MFT table. The MFT entries, the tree, is the most valuable piece of this because it tells you the data. It tells you time and date and folder structures. Those don't exist on the drive. Those exist physically on the drive in the MFT entries. So the MFT entries have the data that makes up that component. Everybody understand? So, and like I said, I can go on. I've got a ton of things here, and these are things that we already went through that basically show you the primary items that we were talking about, perpendicular encoding and things like that. So there's actually a whole list of items that has to do with how data is written to the drive and what perpendicular recording actually does, how the drives are laid out with the data itself. And so, but that's the primary amount of information that then can translate into the special things that you can do with the drives, or even the Atola or the Deepspar or firmware. So, everybody coming along okay? Anybody got any specific questions? Anything good? So, everybody's system still running and doing everything? Now, the final thing was over here on the Atola. It should be done now. It should have finished imaging what we were working on earlier. And everybody should kind of be at this screen. Everybody at this screen? Now, the files that it extracted, if you come back over here, you come to the SATA target, click on it. Now, in the file recovery screen, you should now see, as soon as it's done coming up, it's actually imaged those items now. And it's trying to tell you over there, it figured out, did I copy it? You see on the right-hand side where it says that file is copied? If there was a bad sector, it would tell you in that area, oh, this file, I did not get 100% of it. I got 98% of it. So you can now extract these from the drive. So if you actually see the box right here, it says recovered checked. You see that? So click recovered checked. Now it's going to ask you, where do you want to save them? So hit the browse button, and I'm just going to say, scroll to your C drive, whatever the C drive is right here, and then I'm just going to make a folder with the new folder button that says recovered. Everybody knows how to do this, right? I don't care where you drop them. I re-image these laptops every time. So you can say select folder and say start recovery. And now it will copy every one of those files now down from the hard drive that has been imaged in just those specific sectors. So all the other folders, if I went back and selected a different folder, I won't have those files. I need to at least go get the image of that area. So I'm only getting these particular files. So it's copying the 1 gig from those external drives to the local drive. And even while it's doing it, I can actually go look at that directory. So I can actually jump into there, go to the C drive, go to my recovered folder. Oops, wrong one. Recovered folder. And you'll now see my hot girlfriend, and you'll see all the pictures as it's recovering them. So it'll still be adding them to the folder. You can see the little bar on the right as it continues to increase as it's adding all those, and it's still extracting those. So it does take time. A lot of times the imaging parts and those kind of things can go very fast. The giving the data to somebody, that can be the part that takes a lot of time. So breaking that down, at least from that standpoint, I'm able to recover all the pictures, and I can do any of the area or any of the drive or any of the stuff that I need from that standpoint. So you can see everything's coming off fine from that directory, from that status. And then I can reuse this. All I have to do is to stop the source drive, then turn around and add another drive to it, and it'll start this process all over again. So if somebody's very specific and they say, I would like my accounting directory, that's all I have to do is be specific. And if they're going to have payroll and I got to have it done by tomorrow at noon, I don't need to image the whole drive. I don't need to make a full copy of the device. I can literally just go after the specific folder that I want to get to go get all the data. And there's so much more from this standpoint, like I said, that I can do. And be very specific with types of problems and get a report of the types of problems and deal with them. But fundamentally, this is the basic process for the whole thing. And each one of the screens, as an example, over here so here's my drives. Here's my source drive. Now the source drive that I'm copying, let's say it had a password on it. Now this tool lets me reset passwords. There's actually a process I can reset a password if somebody put it on there. But all the tools, and the forensics tools, even if they didn't add a process to erase passwords, even if they didn't go through that amount of work, they could tell me if I had a password. This is called disk passport. And disk passport is, we're not creative in names. It's the same as a passport for you. It has all your information on it. Well, on the drive, I scroll to the bottom, it'll tell me all the commands that it supports. So there's commands that are enabled and commands that are supported. So these are all the things the drive can do. And so one of those is called security, password protection. If it's on and it's enabled, then there's a section that says it's enabled right here. And if the password was on, it would be right there. None of the other tools are checking for that to let you know that there's a password and you can't copy the drive. So at least if you knew that, you could solve this problem for like $35, because there's other tools out there that reset passwords that are only $35, and you could get rid of the password. The only ones you can't get rid of the passwords using software is Hitachi's. Hitachi IBM drives, they have a special fuse, and you have to short the board, and it causes them to fail, and then you can overwrite the password. So you need a special tool to do that. But outside of the Hitachi IBM drives, you can do it for every other drive with a $35 or $39 piece of software. So, but I think at least forensics tools could at least add these things so that you at least know what those items are. One of the other things is you can actually test. Now this one's going to take a minute for it to run, and I'm going to show you. This tool also handles all the heads individually. So you can specify whether or not you want to turn on and off a head. And what happens here is there's a media test. And the media test, when it runs, actually tests to see whether or not I can read and write to the drive. But this is just consecutive sectors. This is not individual heads. The screen will change. On the first menu, and you can do this, hit Alt-I. And on that first menu, you see there's an option down here called Build Head Map. Do you see that? What this does is it takes the zone tables and breaks them out. Now, I'm not going to say it's quick. It's not lickety-split. When you hit that, it wants to know what kind of drive you have. Now, you have a Mac store. So scroll down to Mac store and then hit Enter. And what will happen is you'll see it initializing a head map, and if it can do it, then you'll see all the zones are being broke down. So it's not moving across the drive while it's doing this. It's only reading a table and interpreting the table. And like I said, I wish I could tell you that this was super fast, but depending on the drive, it can actually take quite a bit of time because it has to parse this data and then enter it into its system. So, it's 1% right now, but you can see I have two heads, and they're known as head 2 and head 4. Now, sometimes drives, when they're manufactured, you should have 0 is the bottom head, and then you'll have platters, and then you'll have other heads. So in this case, what might end up happening is, since I have a 2 and a 4, is I may have 2 platters, and I might have one head on one platter and one head on another platter, and nothing else. Now, the reason that happens is sometimes they made this drive in multiple sizes, and the way that they made sure that you didn't use just hack the drive and make a 80 gig drive, a 160 gig drive or something like that, is they never included the heads, so they took them out. So in this particular instance, you may have parts of platters that aren't being used, or that there may be a holder in place where a head should be. But in this particular instance, I do have 2 heads, and they're known as head 2 and head 4. Head 0 and head 3 aren't there. They can rewire these in firmware. They can basically say anything that they want to say. But with the right work, I might actually be able to turn this into a 160 gig drive or do whatever I want to do. I'd need another set of heads, which I can take from another drive, but you get the point. There's a lot of things I can modify or change so that this kind of stuff will work. And again, not lickety-split here, but when it's done and it's through doing a head map, then I will actually have on that menu that I showed you a minute ago where I was doing the media test, it'll show me every head, and then it will show me whether or not it can read from all those sectors. So if you could read from any of those sectors, then you might have a head that's good, but it's bad in some sectors of the drive. There may be a scratch on the platter or something like that. On the whatever head is good, you can turn it on, turn it off. You can leave those heads the way they are. Now the other tool, you saw I didn't really have to do a lot of work. It didn't take a lot of time for it to show you the heads because it does it on the fly. It uses a little bit of its calculating time. This one's pre-calculating it, so it saves time later on. The other one calculates it on the back end while it's actually processing. It'll actually say, oh, I'm looking ahead to see whether or not I need to turn this head on or turn this head off. And that's why it was so quick. All it did was say, I have 2 heads. It didn't do any of this work. And there's a trade-off. It really just depends on, because I don't have to wait for the job to get done on the other tool to immediately go to it. But this one, once it's done, then I may be faster in the long run. But there's just a small trade-off. But it is going to take time, as you can see, again, 10% of the drive, where the other one was instantaneous by comparison. But every setting that is in this one is also over here from that standpoint. Now we've done this recovery on the Atola. And so again, just about every single thing that I can possibly do here, I have an entire list of things that I can play with on this particular drive to modify or to copy or to deal with things. This one deals with SSD drives. It also does the USB drives. It can image a USB drive to a file as well that actually does in-case images. You can actually make an in-case image if you want to produce an in-case image just like you would if you were using in-case in some other instance. Because there's times where you're repairing stuff that other tools cannot see anymore. So once you've repaired it and you've built this tree and you've done this structure, you might need to extract something that then is usable for all of the tools. So host protected area. Now this is one of the things that I would bring up and that needs to be addressed really important, is that host protected area is this thing where you can divide a drive up into areas that are divided for user and for some other purpose. So for instance, if you have a host protected area enabled, a lot of times there's a CD who's written to your drive, and that pops up a little box and says write your own CDs, or there's utility disks, or there's something else. But one of the things that a host protected area does is it lets you set a drive that is a different size equal to another size. So if you're used to a 40 gig and you're imaging a 40 gig, you don't want to scan a 500 gig drive if you wrote to a 500 gig drive. So when I'm writing to a destination, I might need to cut that drive up so that I can image it and it would be specific and it would be that certain size. So a host protected area lets me write that drive, make that drive pretend to be another size. And it can actually go smaller or it can go bigger. I can actually have a 500 gig drive, I tell it that it's a terabyte. So I can do those kind of things so that I would have access to them. But one of the problems that forensics people don't realize is when you change that host protected area, when I modify that button, it actually writes data to the drive. And that's the no-no. That's what you're not supposed to do to a drive. You're not supposed to modify the drive in forensics, because if the guy's testifying on the stand, he's going to say, I didn't modify it, so I didn't do anything to the drive. So therefore, the integrity is maintained. Now, it doesn't write it to user area. It does write it to the system area, but it is a huge problem that no forensics guys are really being educated on, that when they hit that button, that it modifies the drive, and then they testify they did not modify the drive on the stand. And of course, if I'm there, I know they did. So that's part of the other problem. So So anyway, that is pretty much all I have for you. The time period, I mean, if you want to stay around and wait for the drive to finish doing the heads, then I can show you how you can see each individual head along the way. But it's still going to take another 10 or 15 minutes for it to finish doing the heads, but then you can see the individual head test altogether. But otherwise, that's the last slide I got for you guys. Anybody have any questions? Everybody good? Yes, sir?
In Atola, I know you said you could scan the MFT and looking for the book file directory. What about the slash space? You do that as well?
So when you copy, when it physically is looking at the MFT and you say, I would like that file, it's actually copying the entire cluster, not just the file itself. It is when you extract the file, it's only going to do the file size. So, but it actually images the entire cluster. So you can't stop it from doing 512 bytes versus 4K. Like, it's going to do the entire cluster. So it's going to do the file slack space for those files that you selected. If you want to do unallocated space and all the other space, then you can still image the entire drive. But it does do file slack. So file slack is included on the original drive. When you extract the individual files, obviously you're only getting the file. You're not getting the slack at that point. So it is still there. And that's one of the reasons also X-Ways, if you took that drive then and you put it in X-Ways, X-Ways has a function that says gather slack space and then spit that out as one file. So you could actually separate the slack space from the actual files themselves. So you could examine just the slack space all by itself and unallocated space as well. So X-Ways will actually do that in conjunction. So you would make one pass with the Atola and then go use X-Ways to do that. Good? Are you doing a lot of forensic stuff then? Are you doing any?
Yeah, I have a team who does it for me, but
Okay.
they have one.
Yep. Are they using any of these tools or doing anything?
I'm not sure about our team in Tampa.
Okay. All right. Awesome. So, anything else?
Thank you.
Yeah, you're welcome. Thank you. You guys good? All right. Like I said, you guys can wait around until the head is done, and then you can test the head. It's at about 25% or so right now. So.
Turned it off by accident.
Okay. Well, that's fine. And actually, it'll maintain everything that you were doing. If you turn it back on, it'll actually come right back to where it was. You have to physically start it up, but it will actually remember everything. Even if you lost power, that's one of the key things about these, is whatever you've already done, it keeps everything. You don't lose the work that you already had. All right, I've got cards up here if anybody wants any, by the way. If anybody wants to email me or send me a question, I've got them up here on the table. So.
Very good information.
Well, thank you. Thank you very much. I appreciate it.
We do very much. Little
You're welcome.
bit of imaging. I use a Tableau. I couldn't think of the brand.
Yeah, Tableau.
It's just basics,
Guidance owns it. Yeah, right.
Some pretty cool stuff.
Well, thank you.
For the early days.
Thank you.
Yes, thank you so much.
Thank you.
Anytime. Thank you.
So, yeah, thank you very much, Scott.
Appreciate it.
Thank you.
You're welcome.
Thank you for having us.
Thanks.
Very good.
Well, thank you very much. I
Yeah.
appreciate it.
And you said everything is on your
Yeah,
website, right?
those slides are already
Very
up
good.
on the website, so you just go to My Hard Drive Died, Presentations, and it's right there at the top. And then in a couple of days, the video that I have will be
Yeah.
up there.
Okay.
Okay?
All right,
So
good.
those of us who may have been using FTK, we should upgrade to X tool.
I think X-Ways is a far, far better tool. It is much faster at indexing. I mean, things that took 3 days on FTK to index do it in like 2 hours
And they
on
can
X-Ways.
do some of those features with going from the back.
Yes,
and the-
it can. It can has an imager built in, and there is a reverse function as well, so it can do imaging from reverse. And it has 3 different ways to read drives, depending on types of errors. So there is some helpful things that it can do. It's not as robust as one of these tools for a damaged drive, but it is more robust than any of the other tools that are out there that's just software. Yep.
Very
I was
good.
surprised